So hello everyone. Today we are going to talk about what is hypothesis testing. Okay. So uh, hypothesis testing is if there is any claim or assumption about anything. Okay. So you have to just see that that claim is really uh, you know putting some efforts in real world, or that evidence is really strong. We see like that. Okay, we see like that. So hypothesis testing is you can say we have two types of hypothesis testing. One is null hypothesis and another one is alternative. So if that hypothesis is really strong and putting some effort in real world. Okay, like if I take example a new teaching style is better and it improves the student performance. So if that evidence is really true, then we have a two condition, which is null hypothesis, and another one is alternative. So if that is true, then we will follow alternative hypothesis. If not, then we will reject the null hypothesis. Okay, so null hypothesis means there is no difference, and alternative hypothesis means yes, there is a difference. Yeah, we can use that evidence. So this is our hypothesis testing concept. So now let's talk about uh, what is p-value. So p-value, it tells that how much randomness in our data. Okay, how much randomness there in our result. You can say like that. It shows how likely this result just happened by chance. Okay, it just tell the randomness about the data. Okay, so if the p value is small, it means the result is less random and more real. Okay, if the p value is small, and it means the result is less random and more real. That's why we accept the alternative hypothesis, and always reject the null hypothesis. But what if the p value is large? It means the result could easily happen by chance. So we don't reject the null hypothesis. Topic, which is confidence interval. Okay, so what is confidence interval? So it shows a range where true value lies. Like if you say average height is 170 plus 5 plus minus 5, so it means we are just building a we are not telling the exact value, exact point. We are just guessing, we are just guessing the range. Height can be 175 or height can be 165. So we are about 95% confidence in this concept. Okay, so uh, now talk about what is ANOVA. What is ANOVA? It's a analysis of variance. Use when you have a three or more groups to compare. Okay, it checks if three or more groups means are different or not. Okay, like you are comparing the three medicines A, B, C, and ANOVA tells if at least one medicine works differently, then that's good. And its formula, like ANOVA, F equals to variance between groups and uh, divided by the variance within groups. Okay, if F value is large, difference between groups are real. Okay, sorry, again. If F value is large, okay, if F value is large, difference between groups are real. We will reject null value. Okay, and if F value is small, no real difference, except null. So what is this chi-square test? It is a very important concept. So let's talk about what is chi-square test. So it is used to check if two categorical variables are related or not, and it has a some formula. You can see it's a simple formula, summation and then observed minus expected and then square of the uh, difference of observed and expected. So if x square is large, like g square is large, then the difference between observed and expected is big, relationship exists. If x square like g square is small, data is close to expected, no relationship. So now let's talk about correlation and covariance. What is correlation? Correlation is like measure distance and direction of relation between two features. Okay, it's a measure distance and direction of relation between two groups. And when you are solving the data set, when you are playing with the data set, like you are seeing the features, input features, and you are seeing the target. Okay, then you will see some relation with that using heat map, that they are related and they are not related, they are negatively related, they are positively related, and they are not related. So this is how correlation works using heat map. You can see in your notebook. So correlation means we see the relation between the input with the target, and also with input to input. So it shows us the strength and direction of relation between two features. So it's a simple. So what is what is a covariance? Covariance, covariance tells us whether two features change together. Like if you have ever noticed that when we when we when we are traveling in a car, so when the car speed increases, then our fuel always decreases. So it's a, you can say, negative covariance. What we can say, it's a yeah, it's a negative covariance. And what will be the positive covariance example? uh, we can say like that, if the sunlight increases, then our mobile starts to charge more more fast. Like this, we can take this example. So this is a positive covariance because both the variables is increasing. Okay, so this is a variance. This is a covariance. Okay, this is a covariance. It tells us the two features change together. So uh, if both feature increases or both decreases, so that's a positive covariance. Like if one increases, another increases, so that's a positive. If both decreases, that's a negative. If both the variables are against to each other, then that's a negative covariance. And we have a formula, you can see here. Now talk about r square. R square tells how good your regression model fits data. It is used for regression problems basically, and accuracy score is used for classification problems. And what is type 1 and type 2 error? Type 1 error, like type 1 error is rejecting the null, rejecting true is type 1, and accepting false is type 2 errors. Okay, so now let's talk about normal distribution. Normal distribution is what, like when we have a data, and we are seeing the data, that how the data is look like, using a library, like uh, library of Python, which is Seaborn. So when you are using a library which is Seaborn and you want to see the data, so you will see like the data is bell shaped. Okay, you will see that data is bell shaped and it's a normal distribution. Okay, you will see like a data like bell shaped, like this type data you will see. Okay, this type. So this is a normal distribution of the data, like most data near average, and when the data is in normal shape, like no skewed in the right or left side, so that's a normal distribution. What is a central limit theorem? It says when we take many samples, and their average forms a normal bell curve shape, even if the original data isn't normal. So this is a central limit theorem. What is a logistic regression? We will talk about later about logistic regression. So now let's talk about what is a check test. let's see what we have to study more. Okay, what is jet test? Now we will talk about first feature scaling. Some models, like linear regression and KNN and SVM depends on the distance or magnitude. You can say they are dependent on the distance. They work with the distance. They like distance. So if the salary, like you can take an example, like if the salary of a person is 14k and another person's salary is 16k and another third person's salary is 1 lakh, so you can see the difference between the values. So our model is distance based, as I told. Which model? Linear regression, KNN, SVM. So these are the models which is distance based, so they will confuse, they will not able to learn well. So we have to use we have to normalize them. Okay, we have to just use feature scaling. And if another, if one feature has large values and another small, then model gets biased to toward the large one. So we scale all the feature to make them comparable. So we have some kinds of scaling technique like min-max scaling, like where we scale all values between 0 and 1. But we min-max scaling we use in a deep learning basically. And we have a standard scaler, where we what do where we converts the data to mean 0 and standard deviation 1. Like if height is, you can see here, if height is 150, 160, 170, 80, so their mean is 175, and their step deviation, you can see there the difference between the values here is 1 only. So this is the step deviation is 1. Now let's talk about what is a robust scaler. So as you know that like as I have doing the data set on my Coca-Cola app, so I have used a robust scaler for the outliers. So it basically uses the median and IQ or interquartile range, and it's good for outliers. And another concept of scalar is we have a max ups is scalar. So scalar data between 1 and 1, and it's the best for data where we have a many zeros. Okay, where we have a partial data, we have a lots of zeros, then we have to use a max ups scalar. And if you have an outlier, then how you will deal with the outliers? This is the concept. So we don't need to remove the outlier every time, but we need to understand what is outlier. Outlier is like when the values are different from the normal values, so this is the outliers. So we have a one outlier concept like capping means. Capping means what? Capping outlier we have. So what is capping? You didn't you don't need to remove the outliers, you just limit it to a certain maximum or minimum value. Okay, so instead of deleting the data, put your bring it closer to the rest of the data. Means it is telling that you don't need to delete the data, you don't need to remove the outlier, you just put the you know the uh, outlier near to the or on to the upper and lower value. You have to put all the outlier and put it to the upper and lower value. So this is the concept of capping outlier. Okay, and when we don't need to use outlier, so when outlier are wrong entries like typing error, and those should be removed, not capped. Okay, so then we need to remove outliers. Okay, so when you are using tree based models like decision tree, random forest, so you don't need to remove outliers because they handle automatically. So this is the important concept we have to know. And what is a pipe number summary? What is a pipe number summary? Pipe number summary, you can say like that, it gives a quick idea about the spread of the data. Okay, like it tells us the about the data, like what is the minimum value, what is the maximum value, what is the q1 like 25% data, what is the 75% data, what is q2, what is median. Q2 or median is of course same. So it helps us to gives a quick idea about spread of the data. So what is the users, what is the user of five number theory? It helps to find IQR to detect outlier. IQ interquartile range means Q3 minus Q1, and as I told you, like outliers are data points that are very far from the others.